Digital modes. They're really awesome. They got a lot of capability, and without breaking the laws or after the stuff goes down, they're still awesome. You can get a signal around the world with 10 or 15 watts. It's really awesome. There's a system whisper, WSPR. You go on the internet, you send out your signal on WSJT, FT8 or whatever, and there are remote beacons, or not beacons, receivers all over the world. And you can look at the map of the world and see all the places that your signal hit. So you can make all 50 states in one weekend with FT8. I call it zombie mode because you hit the button that says CQ, you can go pour a cup of coffee, you come, oh, hey, I got Delaware, CQ, and walk away and you come back and, oh, you got another state.
Yeah, it's actually the most boring thing.
It is rather boring, but you can't send data. You can only send the very bare basics of what the thing. Okay, they have different modes, and some of them you're actually doing like the old days of the AOL dial-up where you type and you can see the keys being typed and backspace when they screw up. So there's all that. All right, digital modes, here we go. Digital mode hotspot. Transceiver in a digital mode can communicate using digital voice or data systems via the internet. We use the internet, but we can also use WinLink, which is gateways. So you can use it on 2 meters even. You get into a gateway, and then the gateway sticks it into the internet, and it's the other gateways pull it out, and wherever you are, the recipient of the email, can access your email.
It is email, because you write an email, you can write an email to another M or to anybody's email address.
So it's
using that.
Right. And then if the internet goes down, it goes into the gateway, and that gateway communicates with whatever other gateways it can reach and propagates out across the world. And then you can get, if you can reach, the recipient can hit any gateway, he can pick it up. Because it's ham radio, you have to have a license, but you as a licensed ham radio operator can send an email to someone else that's not a licensed ham radio operator, and they can respond, but they cannot send one into you without you first sending them one. I don't know a lot about it, but I know that because we tested that. It's really good for emergency response. All right. You can receive audio, transmitter keying signals are used in a computer radio interface for digital mode operation. There's a bunch of different ones. We're going to cover some of them.
And in most digital modes, you have to turn your power down because in order for the receiving station to discern the data, if you have too much power going, and I'm talking 15 watts, something like that.
When I started, I had 25 watts, and I got a phone call from a neighbor. So what are you doing? You're doing FT8, aren't you? I'm like, yeah, how'd you know? So you're wiping out the whole neighborhood with 25 watts. Wow. Okay, it's accomplished by connecting a computer line in to the transceiver speaker connection. Computers can be used in conjunction with ham radio in many ways for simply logging contacts and contact information. So whether you're doing a contest or you just want to log your data, you can use your computer to log it. I use a computer log. Using software and sometimes specialized hardware for sending and or receiving CW, so you can literally type on your laptop and it will send out a CW signal. And it comes back, and there are devices that, I'm not sure if it's just software for the laptop, that will decode the Morse code and spit it up on your...
It's usually an add-on box. It also regulates your speed of sending.
For generating and decoding digital signals, so you send it out digitally, then it comes back digitally, and there's all kinds of different protocols, and you can write your own protocol if you have the skills. Connecting computers via ham radio, an amateur radio station, this is the yellow, remember, that connects other amateur stations to the internet is a gateway, like I discussed, okay? The bulk of the work is done by specialized modems or computer software and a sound card. There's a company, Grants Pass, SignalLink. If you have an older radio, you can go to SignalLink, and they got a website, and for not too much money, $100, you can buy a little box that plugs into your radio and plugs into your computer, and it does all the things that a new radio does.
With another $25 for the right key.
Right.
Yes. Or you can just buy a real radio to start with, get an ICOM 7300. The terminal node controller, TNC, they're still out there, but they're older technology. multiple protocol controller or MPC. Notice they're black, so don't worry too much about them. The data station setup, you've got a transceiver, you've got an audio interface. This would be the signal link if you're using a signal link. Or this is a TNC or MPC. It goes into your COM port. The audio goes into your audio card. This is where you connect your computer so that the radio can control, the computer and the radio are talking to each other. And then obviously your PC. And then,
Now, do you have to have a special app for the PC?
Yes,
yeah, you're gonna have to use special software.
but it's not hard to get.
Yeah,
these
it's
down.
free even. You set up the software and the radio on the laptop.
But you have to be able to make the right settings in your radio, and that's the challenge.
Yes, yeah, well, there's YouTube videos for that.
Yeah.
Okay, so we have, okay, so this is your radio, your computer, your station. You send the radio wave out, and it goes into the gateway, okay? It goes into both of these because apparently you can reach both of them. Okay, this is a VHF gateway, and this one's an HF gateway. That's what's going on. So the gateway then puts it into the internet, and all the other gateways, the WinLink servers pick it up. And the other gateways, they go up to the internet and they ask the WinLink server, hey, what do you got for me? And if the internet's down, this will communicate, these will actually communicate directly to each other. Actually, the HF ones will communicate with HF, the VHFs will communicate.
Okay, so if we get into a true SHTF situation, how much of this stuff is actually gonna work? Don't expect it to work when the things
Right.
fall apart.
But if there's a regional problem,
Yeah.
like a major, let's say the major earthquake,
Cascadia goes nuts.
Cascadia, and this place is just wiped out all the way up
The whole
to,
Pacific Northwest is electricity
and
down.
we have bare shells and people are going crazy, and you need to get messages in and out. This will work because you can get a signal out of the area.
These are nets.
Yeah.
Yeah.
HF.
Yeah.
There's all kinds of things that you can get a message out. To establish contact with the gateway station, transmit a connect message on the station's published frequency. Now that should be yellow. That is a question. Unmanned gateway and mailbox stations. To communicate with a digital station operating under automatic control outside the automatic control bands. That's what they're for. The station initiating the contact must be under local or remote control. So we will cover what those are. There's local, there's remote, and there's automatic. So I have a local station, and then I have an automatic station as well, which is the repeater. The repeater operates automatically. Frequency shift keying. It's a method of digital communication. That's where we take the frequency that is that nice uniform sine wave, and we shift the frequency. We tighten it up and loosen it up. Frequency shift. So we're FM frequency modulation, we're changing it with our voice, changes how tight and loose it is. With frequency shift, it's tight or loose, and it's one or the other, on or off, ones or zeros. Using bits of data encoded as tones. Data bits, zeros and ones, are exchanged as a rapidly changing pattern of two different tones shifting from one frequency to another. That's what it is. I don't know why they do it that way, because it would work with either one of those individually as well. The tones would probably going to make it a whole lot easier. The frequencies of a two-tone FSK signal are identified as the mark and space.
That's a question you will likely see.
Yeah, you're honestly with that one's gonna be
They're
under.
really pushing digital, so you will probably see that one. Mark and space are the two tones. The space represents 0, but it's black, so apparently we don't care. And the mark represents 1. So two-tone is mark and space. Now it does matter though, if you flip them, it's unreadable. And that's going to be a question. In true or direct FSK, the frequency of the transmitter is VFO. What's VFO? Variable frequency oscillator. Variable frequency oscillator. It's controlled directly by a digital control signal from the computer representing the ones and zeros of the code. So the computer tells it to change frequencies. AFSK is audio frequency shift keying and putting tones into a voice mode transmitter. So you don't even have to have CW. You can have SSB, you can have AM. whatever the software will allow you to do, a voice mode can also send it out. Popular digital modes, radio teletype or RTTY, PSK31, packet radio is a popular digital mode. Pactor and Winmore, IEEE 802.13. Automatic packet reporting system, this is what everybody's tracking their employees with now.
Yep.
APRS.
And if you want to do this, you can turn that on a system you can have and people can track you.
All right, WinLink, an amateur radio wireless network using packet radio to send and receive email on the internet. Capable of both VHF and HF band operation. Access is via remote messenger server or gateway. Uses a VARA, V-A-R-A digital protocol. I don't know why we need to care about that.
It's the fastest mode. You have to buy a license to use it.
All right, WinLink uses the internet to transfer messages, but it can operate without the internet. Okay, automatic packet reporting system, or APRS, can provide real-time tactical digital communications in conjunction with a map showing the locations of the stations. So, some sort of company, and there they all are. It can tell you all kinds of things.
Okay, one other thing about digital is every manufacturer has their own digital thing.
Yeah.
Like ICOM is D-Star, Yaesu is
System
Fusion.
Fusion,
I don't know what
like that.
Kenwood has.
TMR is open
Yeah.
source. Radio teletype, RTTY, is on the test. Play it. That is radio teletype, or RTTY. That's what you'll hear on the radio. It's the oldest digital mode. This is what your
They watch it.
not this crowd. This is what your dad used to use to get
Okay,
messages.
that's not really true because CW is the oldest digital mode.
All right, it's a 5-bit Baudot code.
I hated repairing teletype.
Yeah. Baudot is the origin of the term baud. Pactor and Winmore, teletype over radio, or TOR, Amtor. That's Amtor. The TOR mode's developed to improve reliability over RTTY. So teletype over radio. RTTY had some reliability issues, or probably on readability. You get a little noise in there, it can screw up your signal. Data is sent in short bursts with error detection and error correction information. So they just put a little bit of extra information in the packet of data they send. Allows you to detect errors and go, hey, that didn't add up. And then a little bit more data, and you can send error correction, you can fix it. There are GTOR, it's more reliable but slow, but there was nothing yellow up there, right? Pactor, packet teletype over radio. Packet teletype over radio. That's what it sounds like on your radio. So when you're going through the spectrum, you're dialing your dial, these are the sounds you would hear for these types. Winmore, Windows messaging over radio. Winmore. That's not WinLink. Its ability to detect the correct errors, it's like Pactor, but can use either FSK or PSK. FSK is frequency shift, PSK is phase shift.
It's not yellow.
No, it's not. Pactor 1 was developed by DL6MAA and DK4FB. That's their call signs. So
Every time you see a call sign starting in D, that is Germany.
there's a list of where, it's an international treaty thing. There's a list of what
If
countries
you
are
type
signed.
in on the internet, international data, call sign database.
And if you're going to get into contesting or long distance DXing, print that out or have it handy on your computer screen, because that's how you tell where the guy probably is. You might be operating.
Your signal landed.
Yeah. You might be operating somewhere else, but he's licensed in a country that you want. Then you want to know that call sign. Okay, Pactor uses FSK modulation. It overcomes shortcomings of Amtor and HF packet. Works well in weak signal and high noise conditions. So that's a really cool thing about digital. noise on out there, just and when you listen to an AM radio, right? That's the noise. The noise floor is whatever level. If you're above the noise floor, you can hear somebody talking. With digital, it can be below the noise floor
And we still make it through.
and still get through because the digital signal can be picked out of the noise
With error correction.
and with error correction as well. So that's the really cool thing. It
And
just,
that's the biggest single driver there is for the digital modes, is because the noise floor is not quite irrelevant, but close.
we have, and we'll talk about it later, is a solar cycle. The solar activity goes up and it goes down. And as it goes up, it ionizes our atmosphere better and better. Right now, 10 meters is going around the world. Whereas when I got into radio in 2015, we were at the trough, and 10 meters wouldn't go across the country. So we're still climbing. And there's talk that it's as good as the 60s or 70s when there was the
No,
last
it's not.
big one. There's people talking.
Yeah,
It's
but
probably
you-
because they've been used to the little low ones.
Right.
Aren't doing real well. All right, so anyway, we're heading towards the peak. It's going to get better and better, and then it's going to get worse. And it does that in a cycle.
And daylight and darkness makes a big
Yeah.
difference in the ionization.
Yep. And we'll cover that in depth as well. JT65 and JT9 also work well in high noise and low power situations. Pactor 2 and Pactor 3 are used today. Uses PSK modulation, approximately 2300 hertz of bandwidth at the maximum data. 2300 hertz on Pactor 2 and 3 using PSK modulation. Automatic repeat request, ARQ. You're going to get that one.
Yep.
ARQ, automatic repeat request, used to eliminate errors. So I send a packet and I send a little bit extra data so that you can do some math at the end and make sure you got the right data, because the only way to get the right number is if calculating this comes out to the same number. It doesn't. Hey, there was an error in that, send it again. It's a little slower because it's got to wait for you to send that, and then it sends the next packet, goes back forth. But it's still
But
fast.
it's almost guaranteed good times.
Yeah, you don't lose things unless you have a lot of issues. Adjust the speed or trains itself to match the conditions. So if they're really rough, it'll slow down. 5 kilobyte per second data rates are possible. Most popular modes for transferring large amounts of data. With Pactor 1 more, when other signals interfere with a Pactor or Vera transmission, you may experience, and these will be in all of the above, I think. Frequent retries or timeouts, long pauses in message transmission, failure to establish a connection between stations. We have a failure to communicate. So those 3 items are probably going to be an all of the above answer. But that is signals interfering with your Pactor or Vera
Or
transmission.
you may get one that says, which of these items does not apply? These 3 plus a junk one will be on there.
I don't think they have a question like that.
Yeah, I think they do.
The connection, and we'll find out when we get to the questions here. Connection is dropped if excessive transmission attempts result in failure to exchange information. So it will drop the connection if it can't make the comms.
And having your power too high is a common problem.
That will cause it to drop. Too much power is not necessarily, well, it's illegal. We are required by Part 97 to use the minimum power necessary.
Everybody look up Part 97.313, I think it is.
But there's nothing that tells you it's too much power. If it doesn't work, you try turning it.
Yeah, try turning it down. Don't try turning it up.
That works pretty well.
Brute force is not always the best.
And ALC is a problem. Now, automatic level control.
Digital voice mode. So you can actually have a digital signal and voice spit now. Just like on your television, because your television is almost guaranteed to be digital. DMR, D-Star, and System Fusion all provide digital voice modes.
And System Fusion is often called C4FA.
That's the one with C4 FM.
Yeah.
Okay. Digital mobile radio, DMR. Digital smart technologies for amateur radio, D-Star. And somebody got paid a bunch of money to come up with that acronym. System Fusion. That's Yaesu. Yaesu proprietary system using C4 FM technology. Data speeds. Data rate is the beats per second, or BPS. Symbol rate is symbols per second, or baud. Data rate equals symbol rate only if one symbol equals 1 bit. Duty cycle considerations. Most digital modes are 100% duty cycle. We covered this. Why is that important? Because you're constantly transmitting, and so there is no averaging. If you're putting out 50 watts, you're putting out 50 watts 100%. And it heats up your radio. Now, it's only going to be 100% watts transmitted. So if you're sending and they're sending, you're going back and forth, then you're really 50% duty cycle.
But they're only looking at the transmit portion of the signal.
Right. So that's just, when you're transmitting, 100% of that 50 watts is going out the whole time. Okay, most modern transmitters must reduce output power to avoid exceeding maximum average power output. Okay, data errors caused by fading, interference, noise, etc. Data errors could be caused by
And
this.
notice, please, none of these slides are.
Right. So this is just for your information.
Be aware that all this stuff exists, but we're gonna zoom pretty much through it.
It's measured by bit error rate, or BER. What's that?
I said it enriches the experience.
It does, but it takes 13 weeks instead of 8.
Right.
Error detection. So you've got errors, you can detect them. Some modes include extra data elements to allow the receiver to detect an error. Our parity bit detects simple errors in a single data character. So you got that 8N1 that you've heard of. Which one's the parity bit?
The one.
The 1 is, isn't it? Yeah. So how many people have ever heard 8N1 or 8N2? Well, come on, I'm not the only one.
It's an old computer language
Wow.
parity bit configuration that allows you to get errors on the fly.
Some errors can be corrected with error detection, with the parity using parity. ARQ, what is it? Automatic repeat.
Come on, you've seen that one before.
We showed it to you.
Request.
Request. Automatic repeat request. It's a question. Automatic repeat request transmission system is a digital scheme whereby the receiving station detects errors and sends a request to the sending station to retransmit the information. So it's coming in, and I use the extra data that was sent to detect errors. I go, up, there's an error. Please send that one again. This is known as a NAC, N-A-K, or NAC request. Joining or breaking into an existing contact is not possible. ARQ protocols such as PAC4 limit communications to 2 stations. If Dave's station and mine are communicating, sending the traffic back and forth, you can listen, but you can't communicate with the other one of them. ARQ protocols do provide a broadcast mode that advertises the station's presence, so I can go on and say, hey, I'm here, I'm listening, I'm ready to take traffic. Also, a monitoring mode is provided so that other stations can listen to the conversation, so you can listen to Dave and I talking. It allows you to determine if the channel is in use by other PAC4 stations, so you don't go and send out a signal over the top of us. Otherwise, if you couldn't hear us, you might interfere with our signals. Bandwidth and symbol rate relationship. The higher the symbol rate, wider bandwidth. So the faster you're spitting out the signals or the symbols, the more band you need, the more bandwidth.
Which means the more interference you can cause.
More interference, the more space you need. If you're in a contest trying to use one of these modes, yeah, you might only find a tiniest little sliver of open space. Okay, most digital mode operations on the 20-meter band are found between 14,070 and 14,100. If you go on into the software, it's probably going to stuff you into one of those, into that area. So FT8, it's already got preloaded frequencies they want you on FT8. Well, if you want to make the most contacts, that's where it'll be, is on easy preloaded one, right? But if the band plan says you can do digital, you can go anywhere.